Okay, this is a pretty interesting problem that we've got here where it's taking a look at the non-constant growth model, but in this instance, rather than find the price, it wants to find what's the implication of the growth rate that's implied by the price. So here we've got MITS Cosmetics Company has a stock price of $58.88. It recently paid a $2 dividend, D sub 0. The dividend is expected to grow by 25% for the next 3 years, and then forever it's supposed to grow at a constant rate, so anything beyond that time period. We don't know what that rate G is, and it's what we're going to need to discover, and suppose that the cost of equity, or SOS, is 12%. So they want to know what is that constant growth rate. Well, let's take a look at how this problem is laid out here, given that information. So what you've got is this. If we were to think of time and versus the dividends that we have, we've just seen something occur, so we're looking at the next dividend. D sub 0 was $2, so the dividend that we expect to see at time 1 is $2 times 1.25, and that's to recognize that 25% growth rate. The dividend at time 2 is going to be $2 times 1.25 squared. The dividend at time 3, $2 times 1.25 cubed. And then we're going to see, after that point in time, we're going to see growth that's moving on at this 5% long-term rate, or I'm sorry, not 5%, but at some unknown rate G, that's going to be taking place. So what we're left with here is this. Ordinarily, what we want to do is to value one period prior what that future stream is going to be. So that would be the dividend at time 3 times 1 plus G divided by R sub S of 0.12 minus G. Now, all of this thing is going to be equal to, so if we look at the cash flows that they're putting in here in some period T, we're going to have this $2 times 1.25 that we'd be looking at in here is the time 1 cash flow that we'd be looking at. So 2 times 1.25 is what we're going to see here. And at time 2, we're going to have 2 times 1.25 squared. The cash flow at time 3 is going to be 2 times 1.25 cubed plus 2 times 1.25 cubed, okay, times 1 plus G, and all of that divided by 0.12 minus G. So those are the series of cash flows. And what we know is that when these things are discounted, they're going to be equal to 58.88. So our job is to do this, is to say, let's take each of these, multiply it by the current discount factor, and add those things up. So in this case, we're going to multiply it by 1 over 1.12. The time period 2 cash flow, we're going to multiply by 1 divided by 1.12 squared, okay, 1 over that. And this whole thing in here, we're going to be multiplying by 1 over 1.12 cubed. And we'll set all of that equal to our 58.88, okay, the current price. So essentially what we've got is this. 58.88 is going to be equal to a series of components that we would be looking at there. The dividend that's anticipated at time 1, and that's basically just looking at $2.50 divided by 1.12. And so on. We keep working our way up to each of these things, try to work our way through. Well, that's what we've represented here overall in this expression. Here's our 58.88. 2.2321, that was the dividend at time 1 of $2.50. But you can see what's happened here, and if you take a look at that component, it says D sub 0 times 1 plus this 25% growth rate. That's D sub 1. That's our $2.50. We're going to divide it by 1 plus the discount rate, and that equals $2.23. The time 2 cash flow is, again, what we're looking at here is D sub 0, and we're going to multiply that by 1 plus the growth rate, and you can see that it's going to be squared, but we're going to discount it back 2 periods, so we divide it by 1.12 squared. Now, when we get to the last figure here, this is the dividend at time 3, And again, we're going to multiply the d sub 0 times 1.1 or 1.25 to the third power. That'll be d sub 3. And we're going to discount it back 3 periods, so this is what that factor would be. But it's multiplied, as we saw in that final period, by this accumulation right here. And again, to give you an idea what that accumulation is. It is the dividend itself. This is the 1 that's being multiplied by there. And it's also that dividend at time 3 times 1 plus g divided by r sub s minus g. And that's what we're finding in this component over here. Now, when we multiply it through, I can take the 5888 and subtract off these two constant components that we have, and that's what's happening here for the 5188 or 5138, is it just says net those things out. Now I'm left with this term versus the net of all of those other terms right here. I can go ahead and take this constant and divide it into that, in which I'm left with 1848, and this is going to be equal to my 1 plus g divided by this 0.12 minus g. And all I'm trying to do here is to isolate those things that involve the growth rate itself. So when you go ahead and do that and simplify it down, so you've got 0.12 minus g times this 1848, and we isolate it over to this, and what we're left with is some information on our growth rate that we're going to be able to pop in there. In particular, our growth rate then, when we solve this last step, is simply say, let's take this $1.22 and divide it by the 1948 that's left over, and it gives us a growth rate of 6.25%. Fairly complicated to be able to work through on the algebra, but if you put it out on paper, you'll probably get the best feel for it. But the key here is that a price is always inferring some interpretation, and this is the information content that that price was revealing to us.